Assalamualaikum and a very good day I bid to everyone. For today's presentation, the title chosen by our group is Tiny Threads, Big Impact, Microplastic Pollution and Heavy Metal Contamination for the subject, Research Methodology and Scientific Writing Group Assignment. Next, I will be introducing our team member. Firstly is me, I'm Natasha binti Gogli and Hebron Brun, Nurul Alysha binti Saldi, Nur Asniah binti Asmadi, and Daniel Hafizul bin Jatin Elias Peter. I will proceed to our background study, which is uh, plastic debris is a global environmental threat due to excessive production and poor waste management. In marine environment, large plastic fragment into microplastics, particles smaller than 5 mm via ultraviolet radiation, mechanical force, and biological activities. Microplastics are persistent pollutants that can be mistaken for food by marine organisms, leading to bioaccumulation and potential toxicological impacts across the food web. Recreational beaches are particularly vulnerable to microplastic accumulation due to high human density and local hydrodynamic conditions.
And next is objective. This study consists of three main objectives aimed at understanding microplastic pollution and its associated environmental risks on selected recreational beaches. The first objective is to quantify the abundance of microplastic in the intertidal sediment of Tanjung Aru, UMS Odek, and Kebagu Beach. This objective is important because measuring the amount of microplastic present help determine the severity of pollution at each location. By comparing different beaches, we can identify which areas are more affected and understand possible contributing factors such as tourism activities, waste disposal practices, and environmental conditions. The second objective is to characterize the morphology of microplastic, including their size, shape, and color, and to identify their polymer type. Different characteristics can provide information about the possible sources of pollution. For example, fragments may indicate the breakdown of larger plastic items, while polymer types such as polypropylene and polyethylene can suggest common sources like packaging material and consumer products. The third and last objective is to evaluate the concentration of heavy metal associated with different plastic polymers. This is important because microplastic can act as carriers for toxic substances. Heavy metals such as arsenic, chromium, copper, zinc, and nickel may accumulate on plastic surfaces and potentially enter marine organisms and eventually to the food chain. Together, these objectives provide a more complete understanding of microplastic contamination and its environmental impact.
Hello everyone, I'm Rosnia. Today I will present the methodology used in our study on microplastic and heavy metal analysis in beach sediments. First is sampling. Sediment samples were collected from the intertidal zones of selected beach during low tide. We collected top 2 to 5 centimeters of sand using quadrat to ensure consistent sampling from each station. Next is extraction. The sediment was dried first before separating the microplastic using the density separation method. Saturated sodium chloride or NaCl solution with a density of 1.2 grams per cubic centimeter was used. Since plastics are lighter, they float while heavier sediments sink, making the separation easier. The third step is morphological analysis. The extracted particles were examined under a stereo microscope with 40 times magnification. During this analysis, we identified the size, color, and shape of the microplastics. This step helps us understand the physical characteristic and possible source of the particles. The fourth step is chemical identification. To identify the polymer types of the microplastic, Micro Fourier transform infrared spectroscopy, or micro FTIR, was used. This instrument identifies the chemical composition by comparing the infrared spectrum of the particles with known polymer reference. Lastly is heavy metal analysis. The sediment sample underwent acid digestion using concentrated sulfuric acid and nitric acid. After digestion, the sample were analyzed using ICP-OES, which stands for inductively coupled plasma optical emission spectroscopy. This method allows accurate detection of heavy metal concentrations in the sediments. In conclusion, this methodology combines physical, mechanical, and analytical technique to identify microplastics and determine heavy metal contamination in beach sediment.
For the result and key findings section, the findings of the study were categorized into four main areas to provide a clearer understanding of the collected data. These categories include the abundance of microplastic, morphological characteristic, polymer type, and associated heavy metal concentration. Each category provides important information regarding the accuracy and potential environmental impact of microplastic pollution on the selected beach. Looking at the abundance of microplastic, Tanjung Aru recorded the highest abundance at 857 microplastic particles per kilogram of dry sediment, while UMS Odek Beach show lower concentration. Kebago Beach also recorded a measurable amount of plastic debris. The higher abundance observed at Tanjung Aru may be influenced by greater human activity, tourism pressure, and the accumulation of waste material in the coastal area. Moving on to morphology characteristics, fragments were identified as the dominant shape, accounting for approximately 50 to 60% of the particles collected. This suggests that many of the microplastics originate from the breakdown of larger plastic material through environmental processes such as sunlight exposure, wave action, and physical weathering. Most particles were smaller than 1 mm in size, and indicating advanced fragmentation. In terms of color, white and transparent particles were the most dominant, followed by blue, black, and several other colors. In terms of polymer identification, polypropylene and polyethylene were found to be the most prevalent polymer type across all sampling sites. These polymers are commonly used in daily consumer products such as plastic bags, packaging material, and containers. The higher occurrence suggests that domestic waste and recreational activity may contribute significantly to the source of pollution. Lastly, for heavy metal concentration, zinc showed the highest concentration among the detected metal, followed by chromium and arsenic. Nickel and copper were also detected across different polymer types. These findings are significant because microplastic may act as carrier of toxic substance by absorbing heavy metal from the surrounding environment. As a result, contaminated particles can potentially be ingested by marine organisms and enter the food chain. Overall, these findings demonstrate that microplastic pollution on recreational beaches involves not only the presence of plastic particles but also potential ecological risk due to the association with heavy metal contaminants.
Hi, Assalamualaikum. My name is Noresha binti Saldi. We'll present the discussion. The higher abundance of microplastic at Tanjung Aru compared to UMS Odek is attributed to anthropogenic pressure from tourism and its status as an open beach exposed to intense South China Sea wave current. The prevalence of polypropylene and polyethylene fragments such as local pollution is driven by mismanaged domestic waste and recreational litter. Heavy metal detected in microplastic act as chemical vectors, so this metal may originate from inherent additive or be absorbed from the surrounding environment via biofilm. Environmental factors like wind direction play a critical role in daily spatial temporal variability of microplastic deposition.
In conclusion, this study confirms that microplastic contamination is present in recreational beaches in Kota Kinabalu and demonstrates that these pollutants are not only widespread but may also pose environmental concern. The result shows that polypropylene and polyethylene were the dominant polymer types, mainly appearing as fragments particles, which suggested that larger plastic materials are breaking down into smaller particles over time. These microplastics were also associated with heavy metals such as zinc, chromium, arsenic, copper, and nickel. The presence of these contaminants is important because microplastic can act as carriers of toxic substances, potentially affecting marine organisms and entering the food chain. Therefore, improving waste management practices and increasing public awareness are important steps to reduce plastic pollution and protect the coastal ecosystem. Overall, this research highlights the importance of continuous monitoring and preventive action for environmental sustainability.